So for this activity, you're going to make a phylogenetic tree for the viruses that we have here. And the first thing that you need to notice is that we have an outgroup. So an outgroup is something that is closely related to all of the viruses that we have, but it's not actually going to have any of the characteristics of those viruses. So the first thing that we have to do then is we need to figure out which characteristic each of these things have. So the way that I like to do this is I like to start with something like the matrix proteins. And I look on here, this matrix protein, it says that it's these things right here. So I see that C has a matrix protein, so I'm going to give it an X. And then I'm going to look around, and it looks like all of the other ones also have those matrix proteins. So I am going to give an X to all of those. Next, I'm going to look at a viral capsid, which looks like this. And it looks like C and F are the only ones that have those. Next, we're going to look at DNA. DNA looks like this, while RNA looks like that. See how the DNA one is darker? So DNA is found in just B. All of the other ones have RNA. And then using this technique, I'm going to complete the rest of the table. Once I have this whole table filled out, I am going to put these things in order. And so I have a table on the back that allows me to organize these. And what I need to do is I need to find the one that is most similar to the outgroup. So the one that is most similar to the outgroup is going to have the fewest of the X's. So if I look here, there are 3 X's for A, so it has 3 differences. B has 2 differences. C has 5, 4, 3, and 6. So I know that B is going to come first, and it has matrix proteins and DNA. And then next, it's either going to be A or E. Doesn't really matter which one I put first, so I'm going to put A. And then I'm going to keep doing this. So now that we have our characteristics, we're going to construct our phylogenetic tree. So first thing is that this represents our outgroup. So our outgroup is closely related, but all of these viruses have something that evolved right here that the outgroup does not have. And it turns out that that something is a matrix protein. And I know that because all of the things have a matrix protein. Now, B has a matrix protein and something else, and it's the most closely related to our outgroup, which lets me know that this must be B. And the thing that evolved just in B is that B has DNA instead of RNA. So knowing what I know about how to build a phylogenetic tree, I'm going to use this table to figure out where everything goes, and then to put the traits onto the tree where they evolved. All right, let's take a look at this and see what we've figured out. First of all, a couple things to notice. It doesn't matter where on this line you put DNA, because it could have evolved very early on or it could have evolved very late, but we know that it happened somewhere only for virus B. Likewise, we don't know which came first, the reverse transcriptase or the RNA polymerase. So it doesn't really matter as long as they're both on this line, which applies to all three of these viruses. And then we also don't care if we put E here and A here. We could just as easily have reversed those, and we could have just as easily reversed C and F, and we'll still have the same answers. And there you have it.